In 1943, the US military pushed soldiers to the brink of death to answer one question. How long can a human survive without a single drop of water? These brutal desert trials weren't just experiments, they were a race to map the exact threshold of human dehydration before the heat claimed more lives than the enemy. Discover the lethal data that redefined survival. Welcome to the Survival Bunker. Here we study the brutal reality of surviving war zones, sieges, and battlefield collapse. Today we are not examining a weapon, a fortification, or a tactical maneuver. We are examining a body. Specifically, what happens to a human body when it is placed in extreme desert heat and denied water, and how the US military in 1943 used that information to fundamentally redesign how soldiers survive in thermal combat environments. The data produced by those trials is still embedded in military hydration doctrine in 2026. The men who generated it nearly died doing so. The North African theatre of World War II introduced the US military to a threat its doctrine had not adequately prepared for: environmental attrition through heat. By 1942, American forces operating in North Africa alongside British units were encountering temperatures that regularly exceeded 45 degrees Celsius in the field. The terrain, open desert, minimal shade, reflective sand surfaces that amplified radiant heat load, created conditions where the physiological cost of basic military operations was far higher than commanders had anticipated. Men were collapsing on approach marches before reaching any enemy contact. Heat casualties were being logged alongside combat casualties in unit after action reports. And unlike a bullet wound, heat injury did not announce itself with a single definitive event. It crept up through progressive dehydration, degrading cognitive function, physical capacity, and decision-making in ways that were difficult to distinguish from exhaustion or poor discipline. The US military's existing hydration guidance in 1942 was built around water discipline, the doctrine that soldiers could be trained to tolerate thirst, ration their water supply, and function effectively on reduced intake. This doctrine had roots in 19th-century desert campaign experience and had been transmitted through military training manuals without rigorous physiological testing. It was, the North African experience was demonstrating, dangerously wrong. The critical question military medical researchers needed to answer was precise. At what rate does dehydration degrade human performance? And at what point does degradation become irreversible? Without quantified answers, water resupply planning, march scheduling, and operational depth in desert terrain were all being calculated against assumptions rather than data. The 1943 physiological trials were designed to replace those assumptions with numbers. The research program that produced the most significant hydration data was conducted under the direction of Dr. E. F. Adolph and his team at the University of Rochester, working in collaboration with the U.S. Army. Adolph's group conducted field trials in the desert regions of the American Southwest, the Mojave and Sonoran deserts, using military personnel as subjects under controlled experimental conditions. The results were published in Adolph's 1947 landmark study, Physiology of Man in the Desert, which compiled data gathered throughout 1943 and 1944 and, remains a foundational reference in human thermal physiology. The core physiological mechanism the trials quantified was the relationship between sweat rate, blood volume, and core temperature maintenance. The human body maintains core temperature within a narrow survival range, approximately 36.5 to 37.5 degrees Celsius under normal conditions, through evaporative cooling. Sweat is produced by eccrine glands distributed across the skin surface, and as that sweat evaporates, it carries heat away from the body. In desert conditions at 45 degrees Celsius with direct solar radiation, a physically active soldier can produce sweat at rates of 1 to 1.5 liters per hour, At rest in shade, the rate drops to approximately half a litre per hour, but does not stop. The problem is that sweat is not drawn from a separate reservoir. It is drawn from blood plasma. As sweat production continues without fluid replacement, blood volume decreases. Reduced blood volume forces the cardiovascular system to work harder to maintain circulation. Heart rate increases, cardiac output per beat decreases, and the body's ability to deliver oxygen to working muscle degrades. Simultaneously, as blood volume falls, the body faces a competing demand: maintain core temperature by sweating, or maintain blood pressure by conserving fluid. It cannot fully do both. Adolph's trials mapped this progression with precision. At 1% body weight loss through dehydration, thirst becomes noticeable, but performance remains largely intact. At 2%, physical performance begins measurable decline. Endurance drops, reaction time increases slightly. At 4%, significant performance degradation is documented: strength loss, coordination impairment, cognitive slowdown. At 6 to 8%, the trials documented severe physiological distress, headache, dizziness, inability to sustain physical effort, core temperature elevation. At 10%, heat stroke threshold is approached. Beyond 15% body weight loss through dehydration, death becomes the expected outcome without immediate medical intervention. The data that shocked military command was not the upper end of this curve, it was actually the lower end. The trials demonstrated that a 2% dehydration level, which honestly could be reached in less than 2 hours of physical activity in desert heat without water, produced measurable cognitive degradation. A soldier making tactical decisions at 2% dehydration was just not performing at his baseline capacity, and, well, he couldn't even subjectively detect that his performance had declined. The impairment was real and measurable by external assessment, while being completely invisible to the individual experiencing it. The water discipline doctrine, the idea that soldiers could train themselves to tolerate thirst and function on reduced intake, was directly refuted by the trial data. Adolph's group demonstrated that the physiological effects of dehydration are just not reduced by prior exposure or conditioning. A fit, experienced desert soldier dehydrates at the same rate and, honestly, suffers the same performance degradation at the same dehydration percentages as an unfit, inexperienced one. Thirst tolerance can be increased through training, sure, but the underlying physiology cannot be modified by willpower. The operational implications of Adolph's data were immediate and structural. The first revision was to canteen capacity and resupply scheduling. The standard US military canteen in 1942 held 1 quart, that's about 0.95 litres. In desert conditions at the activity levels documented in the trials, a soldier consuming 1 canteen per hour during active operations would actually remain hydrated. But a soldier rationing that canteen across 2 or 3 hours, which was consistent with the water discipline doctrine, would enter measurable performance degradation territory before the canteen was even empty. The data made the case for increased carry capacity and mandatory consumption scheduling, rather than just leaving it up to discretionary drinking based on thirst. The concept of water forcing, requiring soldiers to drink on schedule regardless of subjective thirst, was directly derived from the trial finding that thirst is an unreliable dehydration indicator. By the time a soldier feels significant thirst in desert heat, he is already past the 2% dehydration threshold, where performance has declined. Waiting for thirst to drive consumption means consistently operating in a degraded state. The new doctrine required water consumption at fixed intervals timed to environmental conditions and activity level, not in response to thirst. Resupply logistics were recalculated around the trial's sweat rate data. Military planners could now calculate water consumption requirements per soldier per hour as a function of temperature, humidity, solar radiation load, and activity level. generating precise water tonnage requirements for operations at specific distances from resupply points. This transformed water from a variable that soldiers managed individually into a logistical calculation that commanders managed at the planning stage. The trials also identified electrolyte loss as a compounding factor. Sweat contains sodium, potassium, and chloride in concentrations that, over sustained sweating, deplete blood electrolyte levels, even when fluid volume is maintained by water consumption. Electrolyte depletion produces muscle cramping, nausea, and, in severe cases, hyponatremia, a dangerous condition caused by drinking large volumes of water without replacing sodium. Salt tablet supplementation programs, directly derived from the 1943 data, were introduced as a standard field measure for desert operations. The military advantage generated by Adolph's data was not defensive, it was operational. The ability to calculate precise water requirements per soldier per hour meant that US military planners could determine the maximum operational depth achievable in desert terrain as a function of water resupply capacity. If a unit can carry 3 liters per soldier and requires 1.5 liters per hour at operational activity levels in a given temperature environment, its maximum unsupported range before cognitive degradation begins is calculable to the hour. Add vehicle-borne resupply capacity, and the operational radius expands in direct proportion to transport tonnage. This calculation, water miles as it functioned in operational planning, gave US forces a planning precision that adversaries operating without equivalent physiological data could not match. A force that knows its exact hydration requirement and plans resupply accordingly can push deeper into desert terrain and sustain operational effectiveness longer than a force managing water on the old discipline model. The physiological data converted biological limitation into a logistics optimization problem with a calculable solution. The North African campaign and subsequent operations in the Pacific demonstrated the operational impact. US forces in the later Pacific Island campaigns, operating in high heat, high humidity jungle environments that presented a different thermal profile than open desert, but the same dehydration threat, applied the water forcing doctrine and the sweat rate-based resupply calculations to conditions the original Mojave trials had not specifically addressed. The underlying physiology transferred directly. The psychological dimension was documented in unit performance comparisons. Formations operating under the new hydration doctrine, mandatory consumption schedules, adequate carry capacity, electrolyte supplementation, demonstrated measurably better sustained performance in heat than formations still operating under water discipline assumptions. The performance gap was not attributed to training or physical fitness differences between units. It was attributed to hydration status. Adolph's 1943 survival curves have not been superseded. They have been refined, confirmed, and extended by decades of subsequent research. But the fundamental dehydration-performance relationship he documented in the Mojave Desert remains the physiological baseline for military and civilian heat survival protocols in 2026. The U.S. Army's current heat illness prevention doctrine, codified in Technical Bulletin Medical 507, specifies water consumption rates by temperature, humidity, and work intensity that are direct descendants of the 1943 trial data. The consumption tables in that document would be recognizable to Adolph. The numbers are his numbers, validated by 80 years of subsequent research. Modern moisture-wicking fabric technology in military uniforms addresses the evaporative efficiency component of the thermal management equation the trials identified. Fabrics that move sweat away from the skin surface maintain the evaporative cooling mechanism more efficiently than cotton, reducing the sweat rate required to maintain core temperature at a given heat load and, well, extending the time before critical dehydration is reached. The fabric technology is new, but the physiological logic Its SERVs was established in 1943. Oral rehydration solutions and electrolyte recovery systems used by current military and emergency medicine practitioners formulate sodium, potassium, and glucose concentrations based on the sweat composition data first systematically documented in Adolph's trials. The electrolyte balance in a modern military hydration packet traces its specification back to measurements taken from sweating soldiers in a Mojave Desert trial in 1943. In 2026, with global mean temperatures continuing to rise and heat emergencies becoming a documented public health crisis across multiple continents, the survival curves Adolph mapped on military test subjects actually apply directly to civilian emergency preparedness. A person caught in a heatwave without water faces the same physiological timeline a soldier in the Mojave faced back in 1943. The 2% threshold, where cognitive function degrades without the individual even detecting it. The 4% threshold, where physical capacity just collapses. And the 10% threshold, where irreversible damage begins. The data is not abstract. It's a countdown clock that starts the moment water intake stops in a hot environment. And honestly, it runs at the same rate for every human body, trained or untrained, military or civilian, in 1943 or 2026. The soldiers who participated in Adolph's 1943 trials did not volunteer for an academic exercise. They volunteered because men were dying in the North African desert, and no one had the data to stop it. What they produced, marching until they collapsed, sweating into measurement equipment, operating under conditions designed to find the exact point of failure, is still the foundation of every hydration protocol that keeps people alive in extreme heat today. Survival is not willpower over biology. It's precise knowledge of where biology breaks, and logistics designed to prevent you from reaching that point. If this briefing changed how you think about what heat actually does to a human body, subscribe to the Survival Bunker and, share this video. Every share puts this research in front of someone who needs it. Hit the notification bell and we will see you at the next briefing.